Thanks, George. And thanks to all of you for joining the August 2018 webinar of the Sustainable Materials Management Web Academy. This 90-minute webinar is hosted by the U.S. Environmental Protection Agency to provide training and networking opportunities to state and local governments, non-governmental organizations, and other stakeholders interested in sustainable materials management. We thank you for taking time out of your day to participate in this webinar. The built environment touches all aspects of our lives, encompassing the buildings we live in, the distribution systems that provide us with water and electricity, and the roads, bridges, and transportation systems we use to get from place to place. Creating all these spaces and systems requires enormous quantities of materials. Today's webinar will introduce the importance of using and reusing materials in the most productive and sustainable way over their entire life cycles to help address the material and resource needs of the built environment. This webinar will feature presentations from the Carbon Leadership Forum, the Building Materials Reuse Association, and the U.S. Environmental Protection Agency's Office of Resource Conservation and Recovery. The first presentation is from the Carbon Leadership Forum, an industry academic collaboration hosted at the University of Washington, which is focused on reducing the carbon embodied in building materials. The second presentation is from U.S. EPA's Office of Resource Conservation and Recovery's Sustainable Materials Management Program, which is focused on advancing the sustainable use of materials in the construction, maintenance, and end-of-life management of the nation's built environment, such as roads, buildings, and other infrastructure, both to conserve materials as well as to promote community resilience to natural and man-made disasters. And then our third presentation is from the Building Materials Reuse Association, which is a nonprofit education and research organization dedicated to advancing and increasing opportunities for the recovery, reuse, and recycling of building materials in an environmentally sound and financially sustainable way. We will take 2 questions after each presentation, and we'll have a longer question and answer session at the conclusion of all 3 presentations. So feel free to type in questions throughout the webinar. So moving on to today's webinar, please take a moment to note the disclaimer on your screen. The pleasure of introducing our featured speakers. First, an associate professor in the Department of Architecture at the University of Washington. Second, we will hear from Dr. Susie Boxman, a physical scientist on U.S. EPA's Sustainable Materials Management Team. And our final speaker will be Joe Connell, who's the Interim Executive Director at the Building Materials Reuse Association. For the full biographies of today's speakers, please visit our Sustainable Materials Management Web Academy website. Kate, I now turn the presentation over to you.
Hello, thank you very much. I'm really excited to be here. As mentioned, I'm the director of the Carbon Leadership Forum. I'm an architect and structural engineer and faculty member at the University of Washington. And this group is, excuse me, my slides aren't going forward. There we go. So it's a group of industry, academic collaboration. So it's a team that is made up of sponsors that are architects, nonprofits, material manufacturers, structural engineers, and we're coming together to figure out how to reduce the carbon impact of material production. So we work together to identify actions that we can take to reduce the environmental impact of material production, and we work then and create resources for the built environment, ranging from academic papers to handbooks and other publications around this topic. In particular, we have launched the Embodied Carbon Network. This is a place for anybody who's interested in understanding more about the carbon impact of material production to share resources and learn. So all of you are welcome, if you're interested to learn more about this, to join the Embodied Carbon Network. So our motivation for this is trying to understand how our design and construction practice efforts can have an impact on climate change, and recognizing that if we are going to meet the Paris Climate Agreement and then have a reasonable chance of keeping temperatures below 2 degrees Celsius, we're needing to go on a trajectory that it gets us to 0 fossil fuel carbon emissions by 2050. So that's a pretty significant change from current manufacturing and building operations perspective. when we look at buildings, the environmental impact of buildings is from both operating those buildings and from making those buildings. So the operating energy is heating, cooling, lights, electrical loads, and the embodied energy or embodied carbon is related to the manufacturing materials. When in a typical building over its lifespan, about 80% of the environmental impacts are related to operating those buildings, and about 20% are related to material manufacturing and production. But as we work to increase the energy efficiency of buildings and reduce the carbon impact of electricity production, those embodied impacts become larger by proportion. And notably, if we're trying to meet this 2050 target, it's the emissions related that happen now that are the guaranteed to happen. So if we focus on reducing material emission impacts, we're making a guaranteed reduction in the immediate time frame. In order to understand the environmental impact of material manufacturing and production, environmental life cycle assessment is used. So this, sometimes called carbon accounting, this method is tracks the quantities of material and energy consumed through the manufacturing and use and end of life of a product or a process. So we are taking things from Earth, such as clean water or limestone, and then we are emitting things such as polluted water and greenhouse gases or methane or nitrogen. So life cycle assessment is really an accounting method similar to cash accounting, but instead of tracking dollars, we're tracking emissions. And much of material production is highly energy intensive. So the emissions can come from burning of natural gas or consuming of electricity for steel production, but it also can come from driving a diesel truck or a chemical reaction that takes place during cement production. So there is a wide range of emissions that happen throughout the process of material manufacturing, and life cycle assessment is tracking those emissions. Understanding the emissions that can be attributed to a single product can be complicated. So on this flow chart on the right, you can see the different final use products of steel. This is a flow chart from the United Kingdom. So here we have construction products over sort of in the middle here as a primary consumer of steel. And then there are two main manufacturing processes of steel. So there's the basic oxygen furnace, primary steel production, and then there's an electric arc furnace, which uses a larger percentage of recycled steel in the production. So each of these different processes have emissions. Those emissions then need to be tracked and then attributed to the final steel production process. So as I mentioned, life cycle assessment is following a standardized method of tracking and reporting environmental impact that can be of a product. So you can use that, for example, to find the carbon impact of producing floor or the carbon impact of building a building. And you could track that from cradle to gate, so from material extraction through the manufacturing, or you can do it all the way from cradle to grave, so all the way till its disposal, or you could track it cradle to cradle, where we look to try and recycle and reuse and make the end of life product be a material input to new products. Well, our work is focused particularly on the immediacy and global challenge of reducing carbon emissions. Life cycle assessment tracks other environmental impacts as well. These include eutrophication or increasing nutrients to water bodies that can result in algae formations and killing off of a waterway, acidification of both water and soil, ozone formation or smog, and ozone depletion, which is the ozone hole. Life cycle assessment tracks environmental impacts that are able to be measured well and correlated to emissions. Things that are not tracked by life cycle assessment include habitat disruption, the changing impacts of transforming land from a forest to subdivisions, for example. So it is not the only way of measuring environmental impact, but it is a way of measuring large-scale, broadly understood environmental impacts. And notably, the global efforts to track and reduce the ozone depletion have been quite successful, with global collaboration enabling sort of turning the corner and healing the ozone hole. So through global cooperation about tracking and reducing ozone depletion emissions, we have made success there. In the use of life cycle assessment data in the building industry is usually done in a fairly simplified manner, in which we're looking to track the quantities of a material used. So, for example, kilograms of the estimate of the environmental impact of that steel production to get a total estimate. So there are databases of environmental impacts of different building materials. There are also building materials that report their environmental impacts in a label, sort of like a nutrition label, or called an environmental product declaration. So there's data around the environmental impacts of material, and we can understand then the total impact of a building by multiplying it by the quantities of materials that are used. Oh, sorry. When conducting a life cycle assessment, it's important to understand why the study is being performed and what is being performed. So the standards of life cycle assessment are, although there's broad global consensus about how to conduct an LCA, there is a lot of flexibility in how one can do it. So the most important step is understanding and defining what it is that you're studying and why you're studying it, and then defining the scope. What are you including in your study and what are you excluding? So, for example, I might want to evaluate the life cycle impacts of a new office building being built in Seattle, and I want to understand the impacts of structure and enclosure, and I would be doing that because I'm looking to get credits in a green building rating system. And of a single study that looked at the breakdown of carbon impacts in a building for the relative different component pieces. So this is the initial cradle to gate environmental impacts of a high-rise residential tower. And you can see that about 30% are related to the structure. That's a concrete foundation and the concrete slabs and lateral system. Then about a quarter is related to the envelope, so that's the exterior walls and windows of the building. A slightly smaller amount related to the interior partitions and doors and finishes. And in this study, we also included the mechanical and electrical equipment and fixtures and fittings. So also the mechanical ductwork and equipment is about 25%. In a lot of life cycle assessment studies, the focus is on these first two parts, is looking at how to understand and reduce the structure and envelope enclosure. While the previous slide was on the initial construction, the same building was analyzed over a longer lifespan. And what what becomes clear is that the refurbishment of materials, so replacing carpets and refitting out window systems and upgrading exterior enclosure becomes more and more significant. So over 100 years, about half is related to the initial construction emissions, and a little bit less than half is related to refurbishment and repairing, which highlights that the more we can work to extend the life of building components and the reuse building materials, we can have a significant impact on overall life cycle impacts. There are multiple drivers within the building industry pushing to use life cycle assessment. Probably the most impactful has been LEED version 4, which gives points for reporting, using materials that have reported their life cycle impact with an environmental product declaration, and also gives points for demonstrating improvement using a whole building life cycle assessment. Architecture 2030, a nonprofit, has issued a challenge for products, which is challenging product manufacturers to develop low carbon building products. And this is fitting in with a broader push within the building industry to increase the transparency and understanding of the materials that we're using, including health product declarations, declare labeling, and other certifications to confirm that the sourcing of materials is done in a responsible way. I'm going to have just a couple of different examples of applying life cycle assessment in practice. This first one is from Skanska Construction that has been using life cycle assessment to evaluate the carbon emissions of different products and trying to track the impacts of their materials and material transportation, craft worker transportation. They're looking at how much their employees are traveling and the fuel that they're working on projects. So they've developed a method to track different projects and trying to understand where the opportunities for improvement are from a material and a transportation perspective. We did a research project here at the University of Washington trying to understand what is the order of magnitude of carbon impacts of construction. So we compiled a database of multiple different life cycle assessment studies of buildings to be able to identify that typically buildings are less than about 1,000 kilograms of carbon dioxide equivalent per square meter, and they're commonly between 200 and 500. We are really at the beginning of use of environmental life cycle assessment to track and reduce building material impacts. This is very similar to where we were about 10 years ago related to operational energy. So we're hoping to help move the industry to understand what are high carbon building methods and what are low carbon building methods, and encourage us to move towards the lower carbon ones. This is a project that was funded by the U.S. Department of Agriculture to understand the environmental impact of the use of mass timber or heavy wood construction and taller office building construction. And in that case, we built a life cycle assessment model of the structural system, the enclosure, the roof and the walls, and the structure of the foundation. And then we ran a parametric model, changing the column and grid beam spacing, testing out what are the optimum structural configurations for these buildings. And what we found is that the volume of the wood, so on the vertical axis here is the volume of wood and slab in cubic foot per square foot, can range by almost a factor of 2 depending on how you configure the building. So if we're looking to reduce the environmental impact of buildings, we're looking to both reduce the quantities of material that we use and then reduce the environmental impact of those materials. And this study was looking at trying to optimize the amount of material that is used. Just this spring, we published an LCA practice guide. This is an introductory guide for life cycle assessment designed for building industry professionals. It has a general introduction, relatively short, that goes into a little bit more depth than what I talked about here. And then it has an implementation guide breaking down the process into 5 key steps, as well as providing online resources, links to tools, and other examples. It really is an entry-level document trying to understand how do buildings impact the environment, what are those emissions and how do they matter, et cetera. So this is a fairly quick introduction to the use of life cycle assessments to understand the carbon impact of building materials. Again, I encourage you to visit our website, which has additional resources, or consider joining the Embodied Carbon Network. We are a global group of practitioners. It's an online discussion forum, so you can go there and ask questions and get answers, or just see what other people are talking about around this topic. And then thank you very much.
Thank you, Kate. We have time for 1 or 2 questions, so now I'm going to turn it over to Chris for our first question.
Thank you so much, Rita. Our first question is, what are the best sources of training on LCA for policy practitioners who are working in this space?
That's good. You know, I think for policy practitioners, you could learn a little bit from the LCA practice guide in terms of general details. And then there's a document that is a summary of embodied carbon policies globally that was published. I believe it's listed on our resources, and if it's not, is there a way for me to send a link to that after this event, Chris? Because that would be a really good connection for policymakers.
Yeah, absolutely, we can do that. Mm-hmm.
But they're across Europe and in different regions. Vancouver and California have been testing different ways in which to include embodied carbon into policy. So they range from giving zoning benefits to people who are wanting to increase the scale of their building if they conduct a life cycle assessment, to others where they're even starting to establish benchmarks where your building needs to be lower than a certain carbon footprint per square foot.
Great, thank you so much. Our second question is, what are some strategies that can be used to reduce the carbon impact of materials in general?
So if you're looking at trying to reduce the carbon impact of material production, you know, the first step would be to use less material, and so be very efficient in your material use. The next one is then figuring out in that material production. So in material production, transportation is typically not as significant as the actual material production, although it can be significant. Understanding local options is one way of reducing those transportation impacts. In manufacturing, it can be relatively simple, and it can be very difficult to implement. So concrete is a material in which reducing the carbon impacts of a concrete mix can be done by redesigning the mix itself. So using different amounts of cement and alternate cementitious materials and higher quality aggregates, and sort of designing the mix itself to be a lower carbon mix. And so that is something that can be done without changing a manufacturing process. Another aspect is oftentimes the major emission source is through energy consumption. So if you are able to shift the energy production to a low carbon energy source, then a manufacturer can reduce the carbon impact of their manufacturing. And that can be done through on-site renewable energy production, or even power purchase agreements in which a manufacturer, for example, can commission the building of a wind farm and build that to be able to offset their electrical production. Then other ways are about optimizing the material manufacturing process and So some of those require large infrastructure investments, frankly.
Great. Thank you so much, Kate. Sounds like there's a lot of ways. And please keep those questions coming. Right now, we're going to turn the presentation over to Susie Boxman, a member of the U.S. Environmental Protection Agency's Materials Management Team. But at the end of the webinar, we're going to have some more time for additional questions. Susie, the floor is yours.
Thank you, Chris. Just confirming that everyone can see my screen.
Yes, we can.
All right. Well, thank you, Kate, so much for your presentation on the Carbon Leadership Forum. And so as Kate explained in her presentation about life cycle assessment and the Carbon Leadership Forum, we recognize that there's this critical need for kind of life cycle thinking in the built environment. And life cycle assessments and life cycle thinking are key principles of our sustainable materials management program. So today, what I'm going to do is introduce our Sustainable Materials Management, or SMM, program in the built environment and discuss some key life cycle thinking concepts, and then finally conclude by describing the outcomes of a forum that we had earlier this year, where we talked about life cycle approaches to sustainably manage materials in buildings and infrastructure projects. So for a little bit of an overview of what I'm going to talk about, we're going to start with talking about why SMM is important and why EPA is investing in this area. We'll follow this with an overview of SMM and discuss its cornerstone of life cycle thinking. Then we'll tie these two concepts together, life cycle thinking and the built environment. And finally, I'll talk a little bit about our forum on life cycle approaches to sustainably manage materials in building and infrastructure projects, or as I will refer to it as the Built Environment Forum for brevity. And then it sounds like I have time to answer a couple of questions. So our world relies and really thrives on the built environment. We live, work, play, all types of different buildings. And then we use roadways, bridges, tunnels to get from place to place, get to the places that are important to us. And so these structures, we are constantly surrounded by them, we're constantly engaging with them, and the built environment is really an important part of our lives. But, there's always a but, these structures can also present a challenge. Creating our built surroundings can require materials and other inputs like energy and water, and we are increasingly depleting these resources at greater and greater rates. And globally, we're seeing that some of the greatest increases in material demand are actually from these construction materials, from minerals, ores, and industrial materials like clay, limestone, gypsum, building stone, those sorts of things. On top of that, our current infrastructure needs maintenance. We need to rebuild things. We're constantly putting additional demands on our material resources. The 2017 American Society of Civil Engineers report on infrastructure rated it as a D+. They've found that we have the same problems over and over again, that our infrastructure is aging, it's underperforming, and in need of sustained care and action. So while we continue economically as a country to prosper, to build, to meet the demands of our society and improve our modern lifestyles, we also see a demand for natural resources, for the construction of these buildings, roads, and all of the other infrastructure that we rely on. So while we're doing all this building, we also need to be able to find a way to maximize how we're using these resources. Many opportunities exist for increasing the safe use of these resources. We were looking at, we have over 500 million tons of industrial materials are generated in the U.S. We have 110 million residences in the U.S. We have natural disasters. that are increasing the amount of debris generated, and really all of these present a lot of good opportunities. And because of all of these different opportunities, we really need to come together to track and assess trends in the built environment. So we each play a role in creating our future, and by coming together to work towards a better one, we'll be able to devise strategies for reducing the use of our raw materials, find efficiencies in our practices, and improve our bottom line. And so with all of that line of thinking, that's kind of where our sustainable materials management program comes in. Achieving all of the different growth that we need to do is just not possible with our current practices. And there are, different strategies for conserving natural resources. They're all informed by this concept of using the natural resources in a sustainable manner while minimizing the impacts on the environment and human health. And so in 2009, the US EPA published our Sustainable Materials Management, The Road Ahead. And this document laid out the case that we were on an unsustainable trajectory, and that our present use of materials is what is behind much of that trajectory for unsustainable use. The Road Ahead furthered the argument that life cycle materials management has the keys to a sustainable path and provided recommendations to the government. It also provided a life cycle assessment of the US economy to identify some different starting points for having this transition to sustainable materials management. So this document really serves as the foundation for our current and future materials management efforts in the EPA. And so in a few slides, I'll showcase some of those efforts and how our program is taking more impactful sectors that were identified in the report and in how are being used to inform the direction of our program. So EPA pursues SMM, which is an approach for using and reusing materials effectively and efficiently while minimizing the amount of materials we use and all of the associated environmental impacts. What's up on the slide there. It encourages life cycle-based decision making. It encourages collaboration and integrative approaches to address complex environmental challenges that we face every day. It encourages the least costly, most beneficial system improvement, but it's important, it doesn't prescribe any one particular practice. It really encourages looking at all of the options to decide what's right in a specific situation. But it can be a major challenge for businesses, policymakers, academic researchers, or consumers for deciding where and how to act to have this maximum positive impact. For any action, there must be a balance between the speed of response and the need to be informed by science-based evidence. So really through this life cycle thinking or through a systems approach to managing materials, businesses can find opportunities that can enhance and sustain their value while also reducing risk. Governments could more strategically apply their policy instruments and resources, and then collaboration across society can be more effective in finding a balance between societal needs and between the planet's capacity to provide. So there are a variety of different tools and approaches that engage life cycle thinking. We have life cycle assessment or life cycle analysis, commonly referred to as LCA. This is a technique to make more informed decisions through a better understanding of human health and environmental impacts of products, processes, and activities. It is covered by Kate. LCA can include evaluations of air, water, and land, energy, of products, processes, or possible alternatives. You can sort of think of it as an environmental footprint for a building or a material. But this is really just one approach, and it can be pretty complex. It requires you to look at the bounds of your assessment and really take meticulous, detailed accounting of all of the materials that are involved in that product or process. So EPA is actually working on an open source LCA tool to help bring everyone into the space. We're hoping in the near future a tool like this can help organizations understand where the biggest impacts are in their own value chain, and how to be better stewards of the resources and make the most effective use of those resources. Let's see. So then we also have carbon footprint, which is a measure of all the greenhouse gas emissions associated with activities in a product life cycle. We have water footprint, which are kind of similar to that carbon footprint, just looking at quantifying water use and instead of greenhouse gas emissions rather than a carbon footprint. And then there are some other tools. So cost benefit analysis, using that to make better decisions. And then we also have environmental product declarations, which can provide kind of quantifiable environmental data to compare and cross products that fulfill a specific and similar function. But really, when all of these tools are used together or used in contexts where they fit best, that we can support sustainable materials management. So life cycle thinking or life cycle based decision making is critical to SMM, as I've sort of been talking about. It can offer a greater return on investment by systematically and methodology, that's not going to come out right, but by identifying opportunities in the materials life cycle. Investing in areas where the most impact can be made, a similar return on investment can be had. Life cycle information helps the government. It helps set priorities and can help target program resources to where they may be most effective. The SMM and the built environment priority came from this sort of analysis using life cycle thinking. Life cycle thinking can challenge preconceived ideas about appropriate targets and policies to mitigate environmental issues. And it helps us develop policies and programs that don't shift environmental burdens or create unintended consequences, which can often be a concern. And for us, really, one of the important things it does is it helps us identify the key partners and stakeholders for collaboration. So in 2016, we released our strategic plan for fiscal years 2017 to 2022. And we identified 7 strategic areas in our strategic plan based on the Road Ahead report that I mentioned a little bit ago. The first 4 up here are the built environment, food, electronics, and packaging. These are all focus areas because they pose significant life cycle impact, and if addressed from a systems perspective, they really present opportunities to conserve natural resources and reduce negative impacts. We have measurement on there. It's also another critical area, and part of our focus is on enabling web-based data collection. And then we also support international efforts, such as those used to promote resource efficiency with international governments like the G7, the G20, and OECD, as well as efforts by the International Resource Panel to increase availability of research and data on resource efficiency policies. So as we've been talking about life cycle thinking, it's a critical component to SMM, but to talk about that a little bit further, it's really going beyond the traditional focus on production and manufacturing processes to include social and economic impacts over the entire life cycle. Some of the main goals for life cycle thinking are to reduce a product's resource and emissions to the environment, as well as improve its impact on society and economic performance throughout that product's life cycle. So you already probably think like this. Many of you probably do. It's thinking with the life cycle involves thinking through a supply chain. And so this diagram is something that we worked on to really sort of identify, to have a good visual of that life cycle in the built environment. And I'm not going to kind of walk you through it because I want to be sensitive of time, but we really recognize that this is a good way of finding where all those collaboration points are, and that you can use this to identify professionals who can influence the future of our built environment. Some of those will influence design in that planning and design phase to use less raw materials. Some will help set the standard for reusing materials so that they have less of an impact on the environment. Some others will find ways to put materials from a deconstruction site, which we might hear about in a few minutes, to its best use. And others will kind of look at forward-thinking policies that can encourage and facilitate new sustainable practices. Really, the life cycle of the built environment is complex. It's a world where, if you stay in your own lane, you're really going to be preventing a lot of innovation. So when we discuss the built environment and EPA, we are thinking about all of the different players that you can see through this diagram, and thinking about different ways that we can help facilitate bringing these groups together, facilitate this life cycle thought process, and help you all really make unique cross-industry connections to help reduce the quantity of materials that are wasted. So now I'm going to talk for a second. I'm going to talk for a second about our forum on life cycle approaches to sustainably manage materials in building and infrastructure projects. So again, the Built Environment Forum. And so we had this, it was January 30th to February 1st this year. And our goal was to bring people from across the life cycle of the built environment together to establish these unique connections and to identify solutions for improving resource efficiency, kind of with the focus on the built environment. And that was really the main goal, and it was pretty a successful event. We got a lot of positive feedback from many of the participants and some of the external stakeholders who contributed to helping us scope out the agenda for this and helped us with planning it. We also, I want to kind of give a little shout out to the regional planning team who helped us put this together, and then the group of dedicated external stakeholders who really helped us make sure that we were putting together a dynamic agenda and could facilitate constructive conversations between all of the participants. And so we actually had over 100 people attend this and contributed a lot of really great insights as both participants and presenters. And so the top of the slide here shows our forum roadmap, which shows the flow of our agenda. We started out with a discussion of the incentives, requirements, and benefits for adopting an SMM or sustainable materials approaches. Then we looked at next life markets to reflect some of the important concepts of beginning with the next part of life, the next life of materials, keeping that in mind up front. And then we looked at topics related to the design and construction, and we also ended with sessions trying to think about whatever else hadn't been covered. We talked about some circular economy concepts and some other things that weren't obvious that they needed to be talked about in the planning process. So it was our goal to have this be really broad in scope, both in the types of participants that we had attend, so that we had people from across the life cycle, and really it was just a starting point for further conversations, which I think we've been seeing, and just a starting point so we weren't going too deep into any one specific topic. Some of the outcomes of this, our main outcome was just how much everyone appreciated that we brought all these people together, that they were able to interact with people that they wouldn't normally speak with, and they learned new things engaging with all of these different groups. Everyone really recognized that it's important for us to not remain in our silos, that for advancing SMM in the built environment and addressing many of these issues, collaboration is really key. Some of the conversations highlighted that we have a great need for innovation in the built environment sector, and that sustainable solutions are often innovative solutions. But people recognize that there's really also a great need for data and management tools to be able to support the innovators and be able to support the decision makers. Because we are throwing a lot at decision makers. They are increasingly being asked to make really difficult decisions about really complex problems, and they just don't always have enough information available to make those decisions quickly. And the information that they're getting just isn't always consistently reported, nor is it necessarily all accessible. And then we also had some, kind of the last bullet there, participants acknowledged that some secondary materials might have hazardous components. They might not pose a risk due to how those materials could be reused. So what came out of this and is highlighted in a report that we just put out a couple weeks ago were 6 key themes. So the first one up here is collaboration and partnership. You have life cycle data and tools, enhancing secondary materials markets, innovation and research, telling a better story, and shifting paradigms. So this summary document is available, and I think I have a link or at least information about it at the end of the presentation. So just briefly, kind of some of the key things that came out of this report. It kind of summarizes some of the concepts that were covered, and then also lists out some potential actions that could be taken by participants at the forum and people involved in the built environment. And so for each of the different themes, there's a list of these potential actions in the final report. And so for collaboration and partnership, just kind of one example from each of the different themes. So because the forum was so successful in the collaboration and partnership theme, one of the suggestions was that having similar events, or that having the beneficial use summits, which EPA used to sponsor in the past, that would be really helpful to participants. But really, at a minimum, the built environment community needs to work to ensure that this dialogue continues at other events. In innovation and research, one of the interesting suggestions was that governments could help do proof of concept projects. So that would make it easier for engineers and government officials to adopt some of the innovative approaches with less concern. In their lifecycle data and tools, it was suggested that the built environment community really needs to develop consistent quality and application of product category rules, environmental product declarations, life cycle assessments, and health product declarations. All of these are very similar ways of reporting information, but the way that it's done currently can be confusing to industry and consumers. We heard we need to be able to tell a better story about the new industries and jobs that are created through SMM approaches. We need to be able to gather and disseminate this information, as well as best practices on different topics related to materials management in the built environment. We really need to be able to talk about the economic case for how SMM has positive environmental impact. Let's see, second to last is enhancing secondary material markets. So one suggestion was developing a risk assessment framework for recycled building products to be able to inform reuse decisions. And then EPA, we have a beneficial use methodology, and that could be used as a starting point for this endeavor. And then the last one is shifting paradigms. So we heard several different important paradigm shifts throughout the forum. Kind of one of them that came up multiple times was the need to reduce the quantity of materials, quantity needed and used in the built environment. So this idea of reuse should be a fundamental starting point, really, for any project that we are working on, and that we need to be able to do better with less. And so kind of that, let's see, last slide is that, you know, we had this event, we're still engaging, and we're still doing a lot of follow-up work. We have a lot going on at the EPA. I mentioned this forum summary document. The link is up there, and the slides are available for you to download so that you can get to that document, which has a lot of other really great actions to think about. We're also initiating a process to engage stakeholders, looking at community resiliency to natural disasters through improved planning and managing of disaster debris. We are working to increase life cycle data and tools, the availability of these, as well as to collaborate. One of our options we're exploring is a clearinghouse for built environment-related resources. We're planning to conduct outreach to our stakeholders in the C&D recycling community to look at how they can use our existing beneficial use methodology to support making decisions for the appropriate use of C&D materials. And then this is the first of some of our built environment focused SMM webinars, which hopefully you all are enjoying so far, but we are planning to have more with similar topics because this is such an important area, and we really would like to continue getting information out from great speakers like Kate and Joe so that everyone can learn more about those different areas. So I'm going to stop there. Hopefully I didn't blow past all my time and turn it over to Joe or take maybe one quick question.
Thank you, Susie. We're going to hold off questions till the end so that there's time for Joe. So we're going to go ahead and turn the presentation over to Joe Connell, who's the Interim Executive Director of the Building Materials Reuse Association.
Great, thank you very much. Give me 1 second here. All right, I'm assuming you can see my screen. So my name is Joe Connell, and my work for most of my life was as a builder and a remodeler, so I come at it from that perspective. I then got into reuse about 15 years ago, working with the Habitat for Humanity Restores out in Oregon, and I'm now Executive Director of the BMRA. As I think about buildings, I've spent my whole life building buildings, taking buildings apart and renovating buildings. I realized more and more that it comes down to design. You know, and there's a quote from Brad Guy. I didn't quote him here directly. I'm sorry about that, Brad. If waste is really just a product of bad design, as Brad says, action, fact, or material object. Everything we do, everything in the built environment that we're talking about today starts with design. So our conversations need to go back to design. And I think that's what Kate was pointing out so well. By the way, I'm going to go through some of my early stuff here quick because Kate and Susie both did such a wonderful job with a lot of the background information about this. But this one is interesting. If building material reuse is as old as buildings, why isn't it the standard anymore? I don't like to go into the past too much, but I do for this one because I think it's important to understand how we got here so that we know a little better how to get out of this. It's because we got really good at extracting raw materials. Our systems are very good at doing this. This slide with the machine, we're very good at harvesting trees. We're very good at mass production. We got very good at doing mass production because of wars and prepping for wars. A lot of our systems, that's part of what I'm talking about today, is we created systems and economies that made it very easy for us to extract more raw materials very quickly, very efficiently, move them into the mainstream, get them sold, and then because that system is built and it's very profitable, we keep doing that. And so we get more and more stuff. And that stuff is part of our building environment as well. And we've gotten in the habit of just throwing it away. We've also had a lot of subsidies along the way. I like to talk about why, and more on this later, but why a virgin 2x4 is cheaper than a reclaimed 2x4, even though that virgin 2x4 might have traveled across the country 3 times to get to a Home Depot. The reclaimed one that comes from across town is probably twice as expensive. But there's a whole infrastructure built into our system nationwide, worldwide, that allows for this movement of raw materials. And we don't count the cost. Kate pointed out we're starting to count the carbon cost, but there's a lot of cost behind the shipment of that 2x4 that doesn't really get presented when you go to the hardware store or the lumber yard to buy that material. If we really did measure those true costs, it'd be far different price and would point us back to reuse a lot quicker. And we also used to think the world was a lot bigger. I grew up outside of New York and New Jersey and used to see these barges going out to the ocean to dump. And we would go down to the Jersey Shore and we would see all of that garbage coming back up onto the Jersey Shore. We now know the world is a whole lot smaller than we used to think it was. So we have to think about building very differently. So the key question in my mind is, how do we utilize all of this new technology that we've gotten to get back to where we came from, to get back to that ancient system, the ancient systems of reuse, to get back to when a building came down, nothing got wasted because the materials were good, long-lasting materials in the first place. A new home needed to be found for them because it was the most efficient and most effective way to build. We've gotten away from that. The challenge in my mind, the question in my mind here, is how do we utilize all of these amazing new technologies that we have developed to get back where we started? And I think we can do it. There's 4 key elements in my mind to doing this. Deconstruction is one. We have to deconstruct. We have to start deconstructing a lot more of our present building stock. We have a huge built environment. There was a quote earlier about it. It even blew my mind. But we have to start deconstructing these buildings instead of just crunching them up and throwing the materials away. One of the ways that we can start doing this is to create tighter limits on waste in construction locally and regionally. Nationally, that's a big chunk. It all needs to start local, I think. And those limits might be limits on the waste, limits on how things are built, on how things are diverted, things like that. The other element we need to build is an interconnected reuse industry. That's something that doesn't really exist right now. This goes back to the slide with the train and our infrastructure that's been built for moving a lot of materials from raw manufacturing all the way through to our built environment. We have the systems, we have the industry in place to do that effectively, efficiently, and to maximize profit, because that's how it was built and why it was built. We don't have that within the reuse industry, and it's going to be a key element moving forward that we have to develop. And the last here is we need to design for reuse and deconstruction. The last 50 years in particular has made deconstruction much harder. When we talk about deconstructing a home from 1920s, we're talking about materials that come apart fairly easily. When you look back to the ancient times, you had stone, you had big, larger masses that came apart and could be reused easily. Now, with the introduction of adhesives, staples, all kinds of materials like that make it very hard to pull elements of construction back apart. It makes it very hard to deconstruct and makes reuse very difficult for us. Things like contaminants as far as lead and asbestos make it equally as hard. And so designing how we build our buildings so that they can be deconstructed and reused is the key element. So a couple minutes here on who the reuse industry is and how we can encourage them. The reuse industry, as we talk of it broadly, consists of deconstruction outfits, people that actually take buildings apart. Now this could be the single person with a small handheld crane taking a barn apart, and I've seen that happen, all the way through to national organizations that will deconstruct all over the country wherever needed. We're also talking about retailers. retailers, oops, sorry about that, reuse retailers. Those are the Habitat Restores, the other reuse organizations similar to those around the country that handle building materials. It's also all the way down to smaller salvage yards. There's also reuse makers. These are the people that kind of upcycle or upscale some of these materials. People, I know one in Pennsylvania that takes out old flooring, old gymnasium floors, and as a workforce employment program, remills the flooring, repackages it, and sells it back out as flooring. Really nice upscaling project. There's tons more of them all over the country. There's upcyclers and DIYers. This could be any number of things. You see them on Pinterest all the time. People taking old dressers or taking old flooring and turning them into shelving, an old beam and turning it into a bar, things like that. Reuse manufacturing I already covered. Sorry about the redundancy. There's also a lot more going on with architects and designers. A lot of this work tends to be more cosmetic, more decorative. You go into the bar and you see the tabletops and the stools are all from reclaimed lumber, but it's starting to go deeper than that, starting to enter some of the more structural elements, some of the pieces that are less cosmetic and really start replacing some of the bulk of material that's being put into buildings. And then there's reuse remodelers and builders. There's actually quite a bit going on with remodelers who are using materials that they pull out of homes to fashion them back into those homes or using them on other homes. This is, of course, not uncommon with remodelers where it's profitable. We all did it, but there's a new intention to it now, where people are doing it for the sake of the material itself and for salvaging. There's also builders that are building completely with salvaged materials. Not too many of those, but there are a few around. So let me back up a little bit and say what exactly deconstruction is. We define it as the systematic dismantling of a structure in order to preserve the building materials for reuse. Now this can happen either partially, as in what we call a soft strip or a cherry pick, where some of the materials are hand-picked out of it, but it can also happen like in this slide where the entire building is taken down piece by piece in reverse order and maximizing the materials that are salvaged through that. The other thing then is how we move this material. We move it mostly through retail outlets. There's thousands nationwide. There need to be thousands more. I say this because as more and more of us start looking at deconstruction as an option for salvaging materials, for diverting waste, that material needs to go somewhere. We need to make sure that we're not just hoarding it for future landfills. So any work that we do within our communities, within our organizations, we have to make sure that we're also supporting the growth of the reuse industries within our local communities, or we will just be hoarding for landfill later. Upcyclers and remakers, as I said, are a key part of our industry. So is it all enough to turn the tide? These things that I've just described that we're presently doing. I don't think so. They're not really enough because right now reuse and deconstruction are still niche markets. We're very small. We're not integrated into the entire system of building our buildings nationwide. We need to move on to a large scale, starting with design, which goes back to the beginning here. It needs to start with design, and there need to be systematic approaches to large scale reuse and construction and the distribution of materials. So again, it goes back to the train, it goes back to the infrastructure. We need to keep building our infrastructure as an industry and as communities so that we can take a building apart, and move the materials onto new uses effectively. And until we can get to that point where we've got the infrastructure built for that and the community supports it in a way, we're not going to get to the tipping point where we're salvaging as much material as we need to. And like I love to tell people that I live for the day when I can call a local lumber yard and spec a load of 2x4s, and they ask me, do you want new or do you want reclaimed? When we get to that point, we will have accomplished quite a bit. And I think it's attainable, I really do. You think about where the recycling industry was 20 years ago, and you know, it was wide open in front of them. I think we're in the same position right now with building material reuse. What do we need to go to get there? We need more reuse operators and deconstructors. And again, that goes back to building it within our communities, supporting these folks. Deconstruction is a bit more expensive than demolishing a home when you look at the short-term cost of it. When you look at the long-term cost, no way. Deconstruction is far more effective, far more efficient, and far cheaper when you really start measuring the full effect of what it means to crunch up a house and throw it in a dumpster. Go back to Kate's presentation for more on that one. We need more ordinances limiting waste and promoting reuse, not just recycling. Recycling industry has done tremendous work over the last 20 years in mandating recycling. Reuse industry is extremely far behind that, but we need to catch up. The reason recycling took off so much quicker is it was easier to monetize. And that's why reduce isn't even on the radar in a lot of ways, because that one's extremely hard to monetize. We also need systems approaches to distribution of materials. Again, going back to what I was saying before with the infrastructure. You know, part of the reason why a virgin 2x4 at a local lumber yard is so cheap is because the systematic approaches to moving that material across the country are in place. How that was created and why I like that view of the train system was created with a lot of federal money, a lot of heavy investments to move raw materials, and partly for politics, partly for the war machine, things like that. We don't have that drive behind reuse. There's not that monetary drive driving it right now. So we have to look at what is the drive for it, and that's the salvaging of materials, the salvaging of our environment, all of those things that Susie and Kate were talking about before. But we have to get there. And that's why we need everyone who cares about sustainability and materials management to include deconstruction and reuse in their thinking, in their terms, in their whatever technology they're developing. It's not enough to think that we can build a little smarter and cut corners here or there on new materials. We have to be looking at reuse. We have to be looking at deconstruction to meet these goals, to get that needle down below where it needs to be, like in Kate's first slide there. So why is our industry so imperative? Why is deconstruction in particular so imperative here? And that is, like I said, you know, 2x4s, virgin 2x4 is still cheaper, and it's going to be for a while. And I like to tell the story, you know, a door that's created that might be, you know, from Georgia, the lumber from Georgia, and it gets shipped all over the country or all over the world, traveling to its final destination. It's not a vibrant and effective way to move our materials. We need to stay more local, and one of the ways we can do that is to reuse the materials on hand. So here's a nice statistic. It's estimated that about 1 billion board feet of dimensional 2x4 and 2x6 are present in residential housing right now. I've also heard an estimate that up to 30% of that housing is likely to come down within the next 50 years. So that's a lot of material coming down. That's more than new construction can handle, I think. No, sorry, it's more. Sorry, oh boy, I might have got myself in trouble on that one. It's not more, but it's more than it could easily absorb. So we need new markets for it. We need to be reusing this material, finding new ways to use it, whether that means putting back into our housing, and more on that in a second. No, I'll go there right now. Oregon passed an ordinance, or passed a building code change a year ago that allows for the use of 2x4 and 2x6 materials within residential housing, of reclaimed stuff. It was semi-allowed before, but now it's built into the code in such a way that it can't be rejected by a building code official just because it's reused or reclaimed. It has to show similar problems to any new virgin lumber that would be used, such as rot or cracks or splits or something like that. So there's a lot of material in our present buildings that needs to be reused in creative ways. C&D diversion, this is an old statistic, but a lot of recoverable wood is going into landfills still. Part of that, and I don't want to pick on Leeds because they do incredible work, and I don't completely understand the points system, but from what I've heard, commingled lumber that goes into the waste stream and can get sent to hog fueling to be burned for energy and still get points. And in my mind, that's a bit of a miss. You know, we need to be giving points. We need to be giving credit for reusing lumber in its state as lumber, and not downgrading it. That's kind of a recycle mentality. It's not what we need to be thinking about here. Here's a little chart here that Kate might find a little old news, but if you look down the net positive and existing building reuse, you know, most of the energy in a building that's existing and then gets reused is in its original construction. And then a little bit in the reuse of that building, as opposed to standard new construction or even zero net energy new construction, which uses more materials across the entire life cycle. So reusing the existing building is best. Reusing the materials from an existing building is definitely next in line. And this is a very simple slide showing the global warming emissions of wood flooring and soft framing, far less with reclaimed lumber. And again, you go back to that statistic with all of the 2x4 and 2x6 material that is in our present buildings, and this slide starts to really have some meaning to it. The other thing we like to talk about in our industry is job creation. It's estimated that that 7 jobs are created through deconstruction for every 1 job in demolition. And here's a slide of a training that we had with actual students for deconstruction that hopefully went on and got great jobs in our field. The other jobs that we don't really have a measurement of and don't really even know how to estimate are the jobs created as those materials go from a deconstruction site down into reuse centers and DIYers and stuff. It's in the thousands, I'm sure. This is a great photo of some of my old staff at the Portland Restore. We had 70 staff in our stores, all selling reclaimed materials, and that was just in Portland. And we didn't do deconstruction, we just handled the materials after we got them. So there's a huge potential for job creation on a local scale with reuse and deconstruction. So what's up in our industry now? The BMRA is talking with cities all across the country. There's more than I've even got listed here that want to support deconstruction and building material reuse by either some kind of legislation or ordinance or creative thinking around how they divert waste. If any of you represent cities that aren't on this list and would like to talk to me, please do. And what we're seeing across the country, why jurisdictions are looking at deconstruction as an option, there's several reasons. One, like in Portland and some of the other major cities on the West Coast, is infill and gentrification. So beautiful old homes, and sometimes not so beautiful, but older homes are being torn down to make way for larger homes or multiplexes, other office buildings, infill. The other reason a lot of jurisdictions are looking at this is urban blight and abandoned neighborhoods. Cities like Detroit, of course, Baltimore, Pittsburgh, Washington, D.C., Atlanta have huge amounts of abandoned homes that are slated for tearing down. Far better to take those buildings down through deconstruction, create the jobs, save the material, create the jobs through saving the material and selling them on, and keeping the stuff out of the landfill. There's also the old traditional taking down barns and old factories. That's part of our industry from the old days, but still needs more attention. There's also new construction continuing with outdated practices, and that's the one that breaks my heart, because we should know better. This includes adhesives. It includes using more materials than are needed. It includes not designing properly to maximize the use of materials, things like that. And that's really, really sad to see. Needs to change. What is exciting is that we're seeing a lot of cities, counties, and states trying to limit the waste and reusing materials. Salvage materials are more and more being sought after for commercial use. A lot of that is decorative. There's a bit of a concern that could be a trend, and if the trend turns away from using reused materials for decorative uses, we could see some of those materials being wasted again. That's part of the reason why we need to get away from it being a niche market and getting more mainstream and using materials in our construction and in our buildings as more than just decorative. We are seeing a growing DIY market for these materials as well. The really, really fun one I like to see is when architects and designers start paying more attention. We've got a conference coming up next month, and I would say a third of our presenters are designers and architects, which is really, really fun to see. We're also seeing a lot more agencies looking at this for potential jobs and workforce development. Policy examples, we're seeing laws and ordinances that explicitly require reuse and deconstruction, or restricts demolition and landfilling. And Milwaukee, Palo Alto, and Portland, Oregon require a certain level of deconstruction. The one caution I'd say there is that if you're looking at that as an option, make sure that you invest in the infrastructure to make it successful. We talk with some folks who say, yeah, we want to do deconstruction, we want to pass this ordinance, we want to make this happen, but they don't have the underlying systems that will make it successful. So you really want to be careful there if you're looking in that direction. On the horizon, we see research happening for dimensional lumber in mainstream, including building office buildings, increase in government agencies contacting us and looking at this, and an increased awareness in the difference between recycle and reuse. People have used the terms interchangeably for years. We've got to separate those terms out, clarify our language, start using the right language when we're thinking about our built environment, because that's really going to help. And looking at design for deconstruction is really going to move us forward a lot. I'm out of time, so our challenges are we lack serious investment. We are a scattered group that lack high organization, and we're pretty much word to mouth. So we're still a small industry, even though we're national, international. We need to grow. That goes back to a lot of what I pointed out about growing our infrastructure, supporting our systems, creating our systems, supporting people that are doing this work. I love Woodsy. I grew up with Woodsy, and I think our future is with this next generation. They're paying attention. I mentioned a third of the people at our conference next month are architects or designers. Most of them are recent graduates from architecture school. These are the ones that we need to invest in and give them the best tools that we can. I'm going to skip that one real quick and just make sure that you all know about our conference next month. It's going to be in Grand Rapids, and it's a 2.5-day conference. Check us out at bmra.org if you can, and please do join us. All right.
Great.
Thank you, folks.
Thank you so much. Thank you so much, Joe. We're now going to open it up for a few questions. So, Chris, what do we have?
Yeah, thanks so much. So these questions will be for all of our speakers today. We had one question that came in that was asking, for instance, in dealing with like natural disaster debris and making sure buildings are up to code in that way. Are there thoughts among the speakers on how to address both of those goals, both designing for disassembly as well as making a building resilient?
I'm willing to take that. This is Kate. I think that on some levels, it might seem that resilience and material management are contradictory, in the sense that sometimes using more materials will help a building perform better. However, and sometimes using less materials makes a building harder to deconstruct. So I'll give two examples of that. One is if you make a concrete floor composite with the steel construction, they are cast integrally with each other, and it can be harder to pull them apart afterwards, but at the same time, they are, you can use less steel by using a composite construction. Or if you want to make a building perform well for earthquakes, you might use more material in your lateral system to make it stiffer and stronger. So I think that the key issue would be that a single attribute like use less material can't be the only criteria by which we design buildings. And so, as Susie was talking about how it's the interconnectedness of the activities, it's the interconnected understanding of the whole life cycle opportunities. Within each project, each of those things need to be balanced against one another. So it's an interesting challenge of design teams about what are their priorities on a specific project. I don't know. Do others have something to add to that?
Well, the only thing I'd add to that is that I think that kind of construction can be designed and developed in two ways. One is without thinking about reuse, and the other is with thinking about reuse. And I've heard people say that some of the panelized construction methods that they've seen make it incredibly hard to pull things apart. But that doesn't mean the technology isn't there and can't be developed to do it right. And I think it's got to be part of the solution. I don't know how to design those, but I think it's possible.
Awesome. Thank you all so much. One more quick question. I think probably only have time for one more question, unfortunately, but kind of talking about like technology in the future, how do you all feel about kind of like cyber physical systems or about new technologies that will help inform SMM and help inform the built environment in that way to bridge any of these challenges that we see in this field?
Well, the thing that gets me really excited about a potential future is building materials in which the production of building materials uses carbon extracted from the atmosphere as a material resource. So there are developing products or maybe really in the research and development stage, in which either at a smokestack or directly from the air, carbon is extracted from the air and turned into things like aggregate that could be used in concrete, or carbon fiber that could replace plastics and such. So, we have the model of trees taking carbon out of the atmosphere and growing building materials. I think it's pretty exciting to see some of the technological developments of material innovation of extracting carbon, and thinking about that as potential new building materials, and reflecting about how we in the building industry could be more open to innovation and change. So how do we think now about how we would adopt to new materials and be ready to adopt to those materials so that we could be able to be a market draw? I think is a really interesting challenge.
All right, thank you so much. So we wish to thank our three speakers for presenting at today's webinar. We also thank you all for joining this month's Sustainable Materials Management Web Academy, and hope you continue to join us on future webinars. Please take a few minutes to complete the evaluation form and give us feedback so that we can design informative webinars with compelling speakers. We will post the slides for this webinar next week and the audio in about 2 weeks. This concludes today's webinar. Thank you all and have an absolutely fantastic rest of your day.